Welcome to Octorum, the literature review for the obscure scientist. My name is Isabelle Berthelot, your host, with Oliver Hutchins, my co-host. Stay tuned for more. Welcome back, everyone. We're so happy to be here with you again. Oliver and I took some vacation time recently, so it's been like maybe 2 weeks since we last recorded, but we're really excited to start up again. Actually, I was able to visit Oliver in Atlanta where he is, which is so exciting because he's like one of my best friends ever, but I haven't actually seen him in person in like a year. Why are you acting so surprised?
I was like, I'm your friend?
And Oliver even gave me a tour of the micropropagation lab where he works, and it was super cool.
Mm-hmm. Yeah, deep into the world of plant genetics, plant tissue culturing, pretty much everything you can do with plants. I feel like I showed off in about like 30 minutes.
It was amazing. It was so cool. And then he works in a botanical garden too, so I got to see all of the plants in the little area where he is. But of course, whenever Oliver and I have the time to catch up, we're able to reflect on our lives. And right now for us, that kind of carries the theme of change, opportunity, and growth. And so whenever we were deciding for our next podcast episode discussion, we're of course led by the articles that we find to be interesting, but we thought that it would be a perfect time to discuss the science of nothingness, the fruitfulness of absence, and what it can create.
I mean, you presented that very elegantly. I know that's how it went through your mind because it does work that elegantly. For me, you just said, Oliver, do you want to talk about nothing? And I said, absolutely. Right, just the science of nothing. Like you just had me at that, and I'm like, what else can we talk about for the next episode?
Exactly. But I'm super excited about this conversation. I think it'll be one of our most dynamic conversations yet. We talk a lot about botanical sciences, we talk about ecology, but of course, me being a biomedical researcher, I do like to bring it back to people specifically. And so this one's fun because we'll get into topics that directly relate to your life, to your health, things like that, in terms of our human experience. There are so many pieces of literature, scientific and otherwise, that explore the weight of nothingness and the opportunity within it. Our conversation today is mainly going to be guided by the book A Universe from Nothing, written by renowned physicist Lawrence M. Krauss. He wrote this book after one of his lectures, also titled A Universe from Nothing, gained popularity. In his lecture, which was posted on YouTube and is about an hour long, he discusses the origins of existence itself in a very witty and engaging way. And I will say, although this topic is on theoretical physics, which sounds really crazy and hard to understand, it is very easy to follow. He makes it very engaging, and I would highly recommend this to anyone who's interested in sort of the science of the universe, the cosmos, or just the origin of our existence and the Big Bang and things like that. I highly recommend it. He addresses profound questions about the discovery of dark matter, the nature of nothingness, and the future of reality.
Yeah. I really enjoyed just being brought back to that vantage point. You know, I think we said in one of the previous episodes that you can frame like biology, ecology as applied chemistry, applied physics, kind of like in this way to kind of almost treat physics as a subset of biology. Was kind of like my little, maybe a little presumptuous or non-humbled way of thinking about before, which I still think in many ways remains true. But after just just trying to soak in the scale of the universe, I felt pretty humbled by just everything else going on out there. And I just felt very small and weak.
Like nothing, which
like
is
like nothing.
Which is the whole theme of our podcast.
Yeah, so very intentional.
Yeah. On that note, I thought one thing that was really funny in this lecture, right? Because this is a theoretical physicist giving a lecture to what I'm assuming to be physics students at a conference or something. A lot of his jokes are digs at biologists. You know, like if he ever has to show an equation, he's breaking down like what does it mean or putting a picture to describe it for the biologists, which I thought was hilarious because that's honestly on par. You know, I try my best, but pictures do in fact help. So I thought that was really funny. I want to lay a little groundwork though. Physicists, please do not come at me for saying this. If people who are in the world of physics and mathematics are listening, they obviously know this information, but being a biologist, it's not directly relevant to what I do. And there's people who listen to this podcast who aren't in the world of science at all, but who are interested in topics like this. So I do want to break it down, lay a little extra framework. I want to talk about Einstein a little. So if you're someone who knows that Einstein was a very important and smart man, but are not exactly sure what exactly he did, I will explain it a little bit. Einstein was a theoretical physicist who made monumental advancements in understanding space and time, both on a universal level and on a scale which pertains to our day-to-day experience. Some of his top hits, if you will, are the theory of relativity, which marked the understanding of gravitational pull, as well as the speed of light being constant. He also describes the photoelectric effect, in which light delivers energy in quote-unquote packets or whole units called photons. And as discussed in episode 2 of our podcast, his famous E=mc² equation illustrates the conversion of mass to energy. Now, this podcast episode is about dark matter and empty space as described by physicists studying the universe. So to set the scene for this, Einstein was on the job of answering the question of what our universe looks like and how it behaves. Theoretical physics wasn't just applicable to how objects move in the universe, but we can also use it to better understand how the universe moves, and therefore its birth and death. At this time, it was the general understanding that the universe was static, unmoving, and eternal. During this period of questioning the behavior of the universe from Einstein and many other physicists, there were also advancements in technology that allowed us to apply these theories and equations to real objects with known locations. Edwin Hubble, in which the Hubble telescope is named after now, observed distant galaxies, and Henrietta Leavitt's advancement in spectroscopy allowed for measurements of distances of galaxies and supernovae to determine an estimated age of the universe. These observations indicated that the universe was not static, but expanding. This culminated in the Big Bang Theory from Georges Lemaitre, which completed a cohesive narrative about the origin of the universe and the nature of expansion. So in chapter 4, titled Much Ado About Nothing of Krauss's book A Universe of Nothing, Einstein's quantification of the non-static, expanding universe is explored. Einstein was facing a dilemma where there was a great amount of energy that was unaccounted for. Here's a quote from chapter 4, page 56. Oliver, if you could read it.
Let's return to 1917. Recall that Einstein had developed general relativity and had heart palpitations of joy over discovering that he could explain the precession of the perihelion of Mercury, even as he had to confront the fact that his theory couldn't explain the static universe in which he thought he was living. Had he had greater courage of his convictions, he might have predicted that the universe couldn't be static. But he didn't. Instead, he realized that he could make a small change in his theory, one that was completely consistent with the mathematical arguments that had led him to develop general relativity in the first place, and one that looked like it might allow a static universe. While the details are complex, the general structure of Einstein's equations in general relativity is relatively straightforward. The left-hand side of the equation describes the curvature of the universe, and with it, the strength of the gravitational forces acting on matter and radiation. These are determined by the quantity on the right-hand side of the equation, which reflects the total density of all kinds of energy and matter within the universe. Einstein realized that adding a small extra constant term to the left-hand side of the equation would represent a small extra constant repulsive force throughout all of space, in addition to the standard gravitational attraction between distant objects that falls off as the distance between them increases. Einstein called this extra term the cosmological term. Because it is simply a constant addition to the equations, it is now, however, conventional to call this term the cosmological constant. Once he recognized that the universe is actually expanding, Einstein dispensed with this term and is said to have called the decision to add it to his equations his biggest blunder. But getting rid of it is not so easy. is like trying to put the toothpaste back in the tube after you have squeezed it out. This is because we now have a completely different picture of the cosmological constant today, so that if Einstein had not added the term, someone else would have in the intervening years. Moving Einstein's term from the left-hand side of his equations to the right-hand side is a small step for a mathematician, but a giant leap for a physicist. While it is trivial mathematically to do so, once this term is on the right side, where all the terms contributing to the energy of the universe reside, it represents something completely different from a physical perspective, namely a new contribution to the total energy. But what kind of stuff could contribute such a term? The answer is nothing. By nothing, I do not mean nothing, but rather nothing. In this case, the nothingness we normally call empty space.
Before the realization that the universe was expanding, Einstein balanced his equation by adding the cosmological constant, which still represented the behavior of a static universe. But after the discovery of the universe as expanding, the role of the cosmological constant haunted Einstein. It's because it was correct, but now we had this question of what did it mean?
So it was made and justified under the concept of a static universe. So it made sense then. It still had a purpose, kind of independent of the broader logic and understanding conceptualization of the universe that justified it. He put this in there for a completely different reason, but even though that reason kind of dissolved, it still had a place there. All right, I see how that could have driven him insane.
Right, and now it's indicating that there was some energy, like a very significant amount of energy, that is now unaccounted for. We didn't know what mass was connected to this energy, because usually energy, what we're talking about here, it has to do with gravitational pull, because we're talking about the movement of the universe. So now we have this energy of gravitational pull, but we don't know what mass it's linked to. And so that's what haunted him. Energy that exists, a lot of it, but without any visible matter to link it to. This contradiction requires consideration of a new, unknown particle that does not interact with light, is nothing, no thing, but contributes to energy. This unknown is what we call dark matter. It is through this cosmological constant that the nothingness of the universe and dark matter was formed. What's interesting here is after reading through the dialogue of the book, A Universe from Nothing, listening to the lecture, thinking about it, I've sort of realized that they're talking about two different types of nothing. Dark matter is one type of nothing, a mysterious substance that we know contributes to energy and gravity despite not interacting with light or having mass that we can see and detect. But when I read A Universe from Nothing, I was intrigued by another form of nothingness, separate from the appearance of nothingness from dark matter. This other form of nothingness is created emptiness. For the sake of comprehension, let's call this nothingness net zero. Part of Krauss's message in this book is that nothing is often misunderstood, and what we consider to be nothingness has the capacity to create. I would like to read another passage for you. This is from chapter 10 of Krauss's book. The existence of energy and empty space, the discovery that rocked our cosmological universe. Because think about it. Sorry, I'm coming out of the quote for a second. Think about how crazy it is that energy can exist in empty space. Everything that we know about energy right now, it's linked to charge or mass, but now we're talking about energy in empty space. That's kind of crazy. It should, you should feel like that should not exist. And so that's why it was such a big deal to these theoretical physicists. So I'm going to start this over again. The existence of energy in empty space, the discovery that rocked our cosmological universe, and the idea that forms the bedrock of inflation, which is a, cosmological term that I'm not going to go into, only reinforces something about the quantum world that was already well established in the context of the kinds of laboratory experiments I've already described. Empty space is complicated. So what Krauss means here is that quantum fluctuations, basically just another way to say random spontaneous creations, occur in empty space. And they occur so rapidly that we basically would never be able to sense them if they were in front of us. The quantum vacuum, what people might call empty space, is not empty. Instead, it is a sea of activity where virtual particle-antiparticle pairs are constantly popping into and out of existence. The discovery that put Stephen Hawking on the map was a dramatic example of this concept, where he discovered that black holes can emit particles. They do this because within that empty space, that vacuum, fluctuations can cause particles to be created, showing that something can be created from nothing. So the entire purpose of Krauss's book synthesizes this very point, and he argues that a universe and everything that we are could have plausibly arisen from the quote-unquote nothing that existed. It is an amazing journey of understanding, but I want to rest in this net zero concept of nothingness. This is where I want to bring our discussion to, and this is what I want us to integrate with biology. We sort of introduced two different types of nothingness. On one hand, we have what is called dark matter. And dark matter is invisible. We don't have a way to observe or document its mass, and it doesn't interact with light. Yet we know that dark matter has an impact on gravity and energy. On the other hand, we have what I call the net zero nothingness, which can be creative, particles can be created from it, but the net zero nothingness is created because you have a positive and a negative interacting to equal zero. Does that make sense?
So the first one, like dark matter, is just kind of like this metaphysical discovery of this phenomenon of nothingness, and the second one you propose is kind of like the more common understanding of how you can reach nothingness, of just kind of like a nullification kind of concept.
Yes. Mm-hmm. And it both produces and can be produced by the positive and negative, the equal but opposite coming together to create net zero. That's why it's emptiness. To whereas dark matter, you look at it and it seems like nothingness, but there is something there. We just, in our existence, in our world right now, with the understanding of physics that we have right now, we don't know how to measure it, we don't know how to find it, but we know that it exists. Does that make sense? It's nothingness because it's invisible.
It almost feels like, even as you're talking about dark matter, it feels like that definition of nothingness was mislabeling almost. Like, is there truly nothing, or is it just beyond our understanding, so we call it nothing due to our inability to recognize it? Because again, if you're describing it from that place of, oh, it has weight, we just can't see it, that's clearly something. It's just, like, the word that comes to mind is like, it's evasive. It's evasive in ways we never could have expected. And that doesn't feel like a true nothingness to me.
Yeah, and in that way, it is just the appearance of nothingness. To whereas the net zero truly is empty space. But we do run into sort of a brick wall with what we have with physics and science right now, where we do not have the resources to measure it, to quantify it. All we know is the theory behind it and the fact that there has to be some sort of mass that we don't see and can't observe in any way. We don't know where it is, but we know that it must exist. I do want to dive a little bit deeper into the net zero nothingness because I introduced the idea, but I didn't really describe where it comes from yet. Mm-hmm. And that's sort of the bulk of what's really interesting to me. I do want to share one more quote to introduce it. This is a short quote from chapter 4, where Krauss writes, "Zero is a number that is easy to produce. Symmetries of nature often allow us to demonstrate that there are precisely equal and opposite contributions coming from different parts of a calculation, canceling out exactly with precisely nothing left over. And that's sort of where this net zero nothingness comes from. Krauss is linking to matter particles and their antimatter counterparts, which are created as pairs. Now, Oliver, have you ever heard of antimatter?
Antimatter. I mean, this now that you bring it up, I've definitely heard of it, but I can't say I really understand how it's different from dark matter. Oh, does it fall into this secondary nothingness that you're talking about, or just kind of like a net zero nothingness? Or subtractive matter?
It's basically subtractive matter if you're looking at it from the perspective of the matter that we know. But it's essentially, I mean, this was the first time that I had really understood antimatter. Like, I think I might have heard it in passing or something, but I'd never really thought about it. We don't know why our world that we know is primarily made of what we call matter, but there is two different types of matter. There's one that we call regular matter, and then there's antimatter. There's virtually no antimatter that exists now, because whenever matter and antimatter interact, they annihilate each other, essentially explode, destroy each other, and release a lot of energy. Antimatter and matter are the same, but inversed. Instead of protons and electrons, like what matter is made of, antimatter has antiprotons and positrons. In theory, there could be an entire world with people and pets and plants that are all made out of antimatter. It's the same level of realness as the matter that creates our world. It's just sort of the inverse of it. So like I said, whenever matter and antimatter interact, they annihilate each other and are converted into pure energy. And this is how the Big Bang occurred. Equal part matter and antimatter destroyed each other and created the most net zero and energetically rich moment in the history of our universe. Because think about it, at the time of the Big Bang, all of the matter that existed in the world and all of the antimatter that existed interacted, all annihilated each other at once, and released an immense amount of energy. But for some unknown reason that haunts all physicists, there was a slightly higher amount of matter than antimatter, which resulted in a net positive of matter, forming the matter of the universe as we know it. This leftover matter is what eventually formed the stars, the galaxy, and all objects of the universe. So that is why virtually no antimatter exists now, because if it were to come in contact with matter, they would destroy each other. So normal matter just won the war, if that makes sense.
The exact same language was coming up in my mind. I was imagining it as like an archetypal war, just like mostly destroyed each other, but like enough survived to make it through to the other side.
Whenever I was talking about how there was slightly higher regular matter over antimatter, I do want to clarify, to my understanding, whenever I was talking about the quantum fluctuations, which are basically like spontaneous events of creation, in which there exists a space of nothingness, and then particles can be created so fast we don't even notice it, and then they pop in and out of existence, so it's basically like they were never there. That can happen, but in a way where if the particle has a certain size, and to my understanding, ability to move, because that size is related to gravity as well and the energy of movement, if it's able to move in a way where it can escape that fluctuation, then one piece of matter or antimatter can escape while its inverse cannot. And so that's sort of how the seesaw tips a little bit. It's not like one's better than the other. It's not like one is destined over the other. It's just that's just how it randomly occurred. Does that make sense?
Oh, there was no fate component. This is just how it happened to happen, whether we know why or not. And it did ultimately lead in a universe with matter in it.
Yes, and that also relates back to whenever I was talking about Stephen Hawking's discovery with black holes and the fact that black holes can emit particles. Like, keep in mind that he wasn't just saying create particles, he was saying emit particles. And that's why whenever I was talking about, like, based on the size and the charge and the movement of a particle that's created, it can almost escape that vacuum. That's the perfect example. Black hole is a vacuum. The reason why it's black is it even vacuums in light. It's like it's the pull is faster than the speed of light, which is why like things they can appear to be bent along the edge, or it loses all light at all. That's why, it's because it's that vacuum. But if a particle is able to escape that vacuum, then it's escaping and moving forward, and in that way it's being emitted. And that was, not just showing that there are the quantum fluctuations in which particles are moving in and out of existence in a space of nothing, but it also shows that particles can almost escape that. To my understanding, that could almost be one mechanism in which the scales are tipped for matter and antimatter. But learning this through this book and this lecture was very eye-opening to me. Like, of course, I knew that the Big Bang happened, and, I knew that these things were there, but I didn't actually understand what led up to that event. I didn't understand the interaction between matter and antimatter. And for me, this opened up a very large door. Going through what we've talked about in the podcast so far, we've talked about matter and antimatter and how they can cancel out and create emptiness and nothingness while also creating energy. And I'll use the same language as Krauss, the symmetry of nature. We could have a whole conversation about the theories of an alternate universe. Like, those things are plausible. And part of the reason why it's plausible is we know what the alternate universe could be made of. We know what the inverse universe could be made of. There could be something just like this with me and you, and it's all just antimatter rather than matter. But it's the same thing, just inversed. We know that we've never interacted with it, because if we did, we would annihilate each other and be destroyed. For me, this discussion of like alternate universes and stuff, it's cool. Don't get me wrong, it's really interesting. But I feel like I've heard that discussion so many times before, and I really wanted to sit and reflect on the relationship and interaction between a thing and an anti-thing that creates emptiness and energy. That to me is a pattern that I feel like we see over and over and over again in the world. And I feel like it's one that people don't talk about a lot. And I just think, whether or not, I'm not saying that all of these things are inherently connected, right? Like, we're going to talk about non-coding RNA. Not saying that non-coding RNA is the same thing as antimatter. That's not what I'm saying. But just sort of this pattern, this observation of similarity of behavior, I think is so fascinating. Oliver, what are your thoughts on that? Like, sort of the thing and the anti-thing canceling out each other, producing energy. That pattern in itself. To me, that almost shows that nothingness, that emptiness, it still has a story. It still has an origin. It is the product of something, and it can produce something, but we associate it with just empty.
So, just thoughts on the notion of the idea of something from nothing. Something born from a net zero, instead of it just being like a true things cancel out, there's nothing left.
Both. Because I think nothing can be created and it can create. So both something from nothing and the pattern of two inverse things canceling out and creating nothing. And in that way, nothing being balance. A necessary balance.
I mean, I keep on returning to this place of, is nothing really nothing? Like, it just feels like, again, just a word we use when there's a lack of greater understanding behind the scenes, or just kind of like this underlayer of things outside of our observation, where it's not really something from nothing as much as things dipping in and out of the observable world, going somewhere else a little bit, and then just popping back up. Like a dolphin, where they pop up over water. Is there a better word for that?
Jumping?
Jumping. Yeah, it's like thinking about just like dolphins jumping above water, going back under, and then you see them somewhere else. Like that's kind of how I'm treating the idea of something being born from nothing. But again, it's just like to use that image, you would have to treat the whole ocean as a non-understood place, like a nothing space. I'm wondering if nothing even does exist. It feels like it's just a mislabeling to me at this point. But I feel like that might also just mean I have to acknowledge we know very little about the world. Because, I mean, what was the number for dark matter? Wasn't something of just like at least half, like they put out like exact number of just how much the universe is this unobservable dark matter, right?
Well, funny you should ask. There's three different theories of the shape of the universe and the amount of dark matter that we can, predict depends on which shape we're talking about. So, the one that I believe Krauss says that he agrees with the most would be the flat universe theory, in which the universe is forever expanding and it is flat and almost 2D. And I believe that that number is like 1% matter as we know it and more like 95% dark matter. And then there's other ones that might be 70% dark matter. And that might be a closed universe system or something.
Yep. Yeah, so regardless of like the most prominent models, it's all treating dark matter as like vastly outweighing the amount of regular matter in the universe, right?
Yes.
That just makes me almost feel like I have to give up on it because, I mean, like, it feels like what I want to be an invitation to a larger world is actually saying what should be, I feel like under that logic, I'd want the world to say, oh, there's all this matter, and then there's even more matter. Look at all this matter. Like, I feel like that's where that line of logic wants to take me. But instead it's saying, nope, everything more than you already know is just nothing, and we don't know what it is, and we don't know where to go from here. That might be the more realistic, humble, grounded expectation of just, the opening of doors. And I'm finding it more frustrating and I'm not really sure where to go, like, from that point.
It's interesting that you bring that up because Krauss has like two whole chapters fully dedicated to what you just discussed. Sort of people's reaction to the unknown and reaction to what I believe he considers to be like the challenge of scientific discovery. You
Mm.
know, one thing that Krauss is really outspoken about, not to say that he's anti religion, he's not anti religion, but he does make it clear that whenever we're talking about scientific discovery, whenever we're talking about how to factually explain how the world works, it must be done through observation and through experiment and not just like brainstorming, not just coming up with a thought because usually that just ends in like the bias that you have just being pulled out. But he also talks about, like, aside from the religion point, he talks about how some people might find the vast unknown of our universe to be very disheartening and depressing and, almost make them feel like, well, if we're never going to figure out, then what's the point? To whereas he personally believes that that should be a true point of excitement.
Mm.
And I think that that's really cool. He's talking about there's so much unknown and it's our entire life's work to try to just dig at it piece and piece at a time. And
Well, I mean, even that on its own was already kind of crazy for me because after you said that, that already took me, kind of like flipped me over again where I'm like, oh, wait, something can come from nothing. So it feels like I'm fluctuating back and forth between those states of maybe nothingness is the invitation for a curiosity that I wanted it to be. Again, like maybe nothing is something.
he says, a universe without purpose or guidance may seem, for some, to make life itself meaningless. For others, including me, such a universe is invigorating. And so he's talking about the desire for scientific discovery. He's saying no matter what happens, no matter if our universe just ends up like collapsing in a million years, and that seems really sad and devastating, it's like that is what it is. And we need to look at it with open eyes and we need to try to understand it. And he's saying that all of this unknown just leaves room for things to chase. The last quote that I'll read is he says, There is much that science still does not know, and in parentheses, and it is working on it with rolled up sleeves. You know? I would like to get your thoughts on the net zero concept, both as something that exists in the time that we're in now, but then also during the time of the Big Bang, right? Because in order for the Big Bang to have happened the way that it did, there needed to be that symmetry of matter and antimatter. Like, that's what created the Big Bang. That's what created the explosion, the annihilation, the energy. It was the symmetry. And so the idea that that is sort of the state of the universe and of existence, or at least that was the original state. And then also the balancing of the symmetry is now a tool that is used to create balance, right? Because sometimes the creation of nothing is required for balance, for calm, for peace. And so I would like to get your thoughts on that. And also, I will add the idea that nothing is extremely unstable. You know, I talked about those quantum fluctuations, particles coming in and out of existence in nothing. But even that, you know, people question, oh, well, how could the universe come from nothing? And he's saying nothing is so unstable, there's no way that it could have just remained nothing forever. And so in that way, nothing being unstable and a creative force. And the product of symmetry.
Oh, I think I'm feeling something there, or I think where you're getting with that. For me, it's almost registering as this sense of limitless potential, like the only way to have the potential to be anything is by being nothing. Because if you're something, you've been tied down almost like in a form of commitment. But again, seeing that as not a not neutral thing, like I see what you're getting at of just kind of the idea of nothing as a meeting of both a positive and a negative, like a very active, not like the number zero, but positive 1,000,000 plus negative 1,000,000, still making zero, focusing on the product and not the process that led it, being a very active one. Like it makes me think of, I guess I'm feeling very militaristic today, but the idea of, you know, no man's land in a war of you have two global superpowers sending every bullet, bomb, force you can imagine at each other just to create this little strip of land with nothing on it that is not moving, but again has the potential to generate an insane amount of movement at the same time.
That's why whenever I was describing the net zero emptiness, I also said created emptiness. Because it, in that way, like, it appears to be just zero, but it's zero because, like you said, it could be positive 1,000,000 plus negative 1,000,000. And those two things are very large and volatile, and yet they are symmetrical. And that results in nothingness. And I do want to just, because we're talking about this, I went over how our world is dominated by matter because the scales were tipped in the favor of matter. And because they destroy each other and release energy whenever they interact, and because there was more matter, now there is zero antimatter. Is that clear? Like, just because that's the foundation of what I'm saying. That's clear.
Yeah, just kind of, again, in the net zero kind of ways, like they have neutralized each other, so it is not here anymore.
Yes. But, of course, I would do the same thing. For physicists and theoretical physicists, they're like, we want to see antimatter. We want to understand antimatter. We want to be able to observe it. We want to see it. And so that's been a whole, like, research, deep dive into creating or observing an antimatter particle. Antimatter has been produced and can be produced, although it is very difficult. To my understanding, the way that it's produced, it's almost like the reverse of the annihilation that happens whenever matter and antimatter interact. It's like, instead of annihilation, release of energy, if you imbue something with very high amounts of energy, it's almost like that can dissociate again.
I was revisiting that in my own way as you were bringing that up too, of just how much energy it takes to create antimatter. Of it almost feels like there's this kind of like physical tendency or like path of least resistance to manifest in the form of nothing. So again, in asking that question of how could matter and antimatter meet and still there just being something left over, it feels like energy, matter, however you want to frame it, or I guess kind of like it feels like energy is always trying to be something because that is a more stable, restful state than just pure nothingness. I mean, I'm almost imagining like the only word that comes to mind is like grace. Is like that's what keeps emerging for me of just kind of the idea of what feels like should result in complete neutralization or like destruction does inevitably result in something left over, just out of the virtue of that is simply how things go.
I do want to dive into a real world example of how these symmetries, these inverses interact that aren't just quantum theory, because that's very hard to wrap your head around. And I think what you just said about grace as well, like that's sort of what drew me to what I'm about to talk about, because it's all concepts in immunology and physiological regulation and things like that. And to me, whenever we're talking about the theoretical physics of the matter antimatter, the net zero thing, having chaos and then having calm, balance is necessary for the universe to remain in a calm state, right? Like even all organisms, although the universe is not living, organisms are. All organisms, the goal is to maintain equilibrium, right? And that is something that is an active pursuit. I love immunology because it's like a whole network of maintaining equilibrium. I mean, yeah, you could say that for physiology and stuff too, but to me it's all like it's all already figured out. It's like buttons and levers and all this stuff. Immunology, it's like a consciousness of maintaining equilibrium. And so whenever I read this A Universe from Nothing, it immediately made me think of two things. Well, really one thing, and then it led me to another thing. Non-coding RNA. So what do you know about non-coding RNA right now?
I saw the word non-coding RNA for this episode. I remember I got like a brief flash of memory from a genetics class where they were like, by the way, there is some DNA or RNA that doesn't do anything. And then they moved on. And I think that was about the beginning and extent, or the beginning and the end of it. Just, it
Yeah.
is there.
I mean, I will say the world of non-coding RNA is newer. Like in terms of scientific discoveries and what we know about organisms, it's newer. But for our listeners, can you summarize, we talked about it in, I think it was episode 2, we talked about it in depth. But can you just re-summarize the central dogma of biology for our viewers?
I would love to. Yeah, so the central dogma theory of biology, again, the heart of all life. Every living being in the world, every species, every cell is united by this. It is that, DNA is the blueprint of all living things. That's where all of our genes exist, all the instructions for building a life. DNA is read to produce RNA, a little single-stranded chunk from the core DNA whenever it's needed for whatever purpose. It is then translated into protein expression. So a chunk of RNA is produced off of the DNA, that RNA is read, and then proteins are produced that then build everything needed to build a living thing.
Right. So we have DNA, which is transcribed to RNA, which is translated to protein. And so using that, the entire end goal in every organism, every living cell, is the production of protein. That is why we have DNA. That is why we have RNA. Or so we thought. And so the idea of non-coding RNA sort of was mind-boggling for biologists because all we know is that we go from DNA to RNA to protein. And so then all of a sudden we have these RNA structures that do not go to protein. None of them go to protein. None of the functions are related to producing a protein. I will say that's true like 90% of the time. there are non-coding RNA that, although they're called non-coding, they still are expressed to create regulatory proteins. And so there are some non-coding RNA that still create things. But for the most part, we're talking about like microRNA, circular RNA, all of these things where there's no protein that is built. It only exists as the RNA strand. And that should create alarm bells in your head, because that's really weird. Like, what would be the point? Let me give you a little context on what non-coding RNA does. Whenever there's a piece of RNA that is produced that normally codes for a protein, in most genes, there is also antisense RNA, which is another way to describe non-coding RNA. There's antisense RNA for that fragment that is produced, so that whenever the regular RNA is created, if for some reason that needs to be silenced, antisense RNA can partner with the complementary strand of regular RNA, and whenever they're connected, it either triggers degradation of the RNA or
nullification, where it's just kind of like attached to it and it's no longer functional.
right,
Yeah.
because in order for translation to occur, it has to be single-stranded. RNA plus antisense RNA equals nullification, equals void, equals nothing. But as we've learned about RNA and this whole field of like the interaction of non-coding RNA and regular RNA, it's called RNAi, RNA interference. It's an entire emerging field in biology, and we've realized, crazily enough, we've realized that only around 3% of RNA is turned into proteins. That's insane. That would mean that around 97% of RNA is non-coding RNA. That seems like a whole lot of instructions that produce nothing. So it really challenges the entire idea of central dogma, but it becomes so important because the merge of RNA and antisense RNA that equals nothing, like deletion, that allows for so much regulation and balance of our bodies. Like, that has to do with the immune system. It has to do with so many aspects of development of the body. Oliver, I did link a paper where we don't need to go into it here, but I even linked a paper. The research of RNAi is huge as it relates to plants, because we've realized that every step of the developmental phase of plants happens because of non-coding RNA. It's like, it's not that new genes are expressed and new proteins are created. No, it almost seems like the opposite. It's like genes are torn down, genes are silenced, there's removal. It's not creation, it's removal. And so I actually sent you a paper that talked about the ripening of fruit.
No, I really loved that one. I mean, I remember reading the title and I absolutely adored it. Yeah. Profiling of short RNAs during fleshy fruit development reveals stage-specific sRNA-ome expression patterns. I mean, you know I'm a sucker for fleshy fruit development.
Same here.
Yeah. But no, I went crazy for this paper too, because, I mean, I have a whole little, my own understanding of plant development as it could relate to non-coding RNA to go on, whenever you want me to go on that.
Go on it.
Yeah. Yeah, I mean, I really adored reading this paper because I think it spoke to an understanding of plants that I've been developing for a while, but...
Since you're talking in depth about the paper, go ahead and, say the name.
Yeah.
I'll tag it.
Yeah, so the paper that, kind of spurned this whole line of thought for me was Horianu et al. 2011, Profiling of Short RNAs During Fleshy Fruit Development Reveals Stage-Specific sRNA-ome Expression Patterns. Now, and again, as Isabelle was saying, it was really just establishing how huge of a role non-coding RNA plays in the development of, in this case, fleshy fruits of a tomato plant, but as a whole in plant developmental pathways. And the way that this spoke to me is I was thinking of just, observing in my own life, I've been spending a lot of years just watching plants grow and how they do it. And even just in the line of like plant development, what you hear, there's always a sense of people saying, there's this incredible complexity of development, diversity of life, of the ways in which things unfold. But at the heart of it, there's probably something very simple that's kind of regulating how all that happens. And this whole idea of nothingness is kind of making that happen for me. And I mean, the place that I see that a lot is to throw in or just sprinkle in a little bit of plant anatomy terms for y'all. If you think about a very basic model of a plant, you have a stem with leaves and branches coming out of it. And then between the branch and the stem, you have a little bud or point of growth tissue called the node. And from that node could either come a branch, a leaf, roots, a new stem. It's kind of like, the little growth point in the plant where there's just pure cell differential potential where anything can happen, basically. And it's kind of the heart of all plant morphology because it's this little growth point where the plant can basically grow whatever it needs to at whatever level. And again, going back to the plant clonal episode, it's basically the whole foundation in which a plant can modularly clone itself to infinity. And in that understanding of the node as like a foundational functional point of the plant, there is the internode, which is just the chunk of stem, or just, the stem that exists between the two nodes that isn't really anything. Like, it always feels like something that's easy to think about because it's, it's the area where growth is not happening. So it feels almost kind of like this blank nothing concept. But if you really look at plant development, so much of it is modifications of that internode, of basically just how big of this nothing space is there. For example, if you take out all the space, like all the stem in between branches, so you have nothing but branches stacked on top of each other, that's how you get a cabbage or an onion. You have all these leaves very tightly packed together that form either storage organs or huge flower heads, something like that. You take this same distance and stretch it out really, really far. That's how you get a vine. Again, it's still just a plant with root, stem, branches, leaves. It's just long enough now that it is able to crawl among other plants and then establish itself in the canopy. And then you take, a more middle ground of that where you have a pretty regular spacing of internodal distance in nodes and then amplify that over time. You get something that looks like a tree. So you look at like the consequences or like the downstream effects of the modification of this little nothing space, and you get this deep diversity of functional plant form that gives you like one metric to understand the full diversity of plant life. But if you really look at like how it's happening, it's this little modification of just non-growth space. And so reading this paper that's talking about how much of plant development is regulated by nothing RNA or non-coding RNA, that totally makes sense. It's like, oh yeah, it's not about those nodes, like it's not about the points in which growth happens as much as what we put between the points in which growth happens that determines the entire anatomy of the organism.
Mm-hmm. In a world, especially within biology, where we're so hyper-focused on what is there, what is produced, what is there, like what is the cell, what is the protein, looking at it from a completely different perspective of what is not there, what is canceled out, eliminated, what is net zero, and looking at regulation of any organism, whether it be a plant or a person in that way, to me, it's a very new perspective. And it's interesting that we don't learn it as much because that is the reality of organisms. Like I said, around 97% of RNA is non-coding. That is the regulation mechanism, more so than production of proteins even. And so I think that looking at it from that approach, like in a world of science where we're so focused on what is there, considering the science of nothingness, to me, is very profound.
Or even just like the nothingness in between. I mean, the other way I've started thinking about this again from kind of like a more softer humanities kind of perspective is just like the science of relationship. Relationship is defined by the space in between. Like if you think about net zero as a truly kind of like singularity, single point, it takes all the life out of it. It's like whenever you think of net zero as, a positive infinity with a negative infinity facing each other, that's incredibly dynamic. There's a sense of something. But if you take all of that and just say it's the number zero, you're taking like all the life or kind of like all the meaning out of it. And I think about just any sense of relationship at the same way of just, it's not about the things themselves as much as how they interact with each other and kind of like the stage or the space in which they are able to interact with each other. That's kind of like the nothingness in between. It's like that's the only thing that really makes it possible,
Yes. And to me, the big theme there is balance, right? Like if we look at the number zero, we don't understand the balance that it holds. But I want to emphasize why this concept of anti-thing plus thing is so important to me is like I said before, the entire role of organisms is to maintain equilibrium in our environment. It is to maintain balance. Like I said, that's why I like immunology. It's an active force of balancing with the external world. And so I do want to give some like concrete examples of this concept of RNA and antisense RNA and what happens whenever the balance is skewed, because it's so real and it's something that I think is not studied enough. I mean, it is coming, it's seeping into the world of science research. Like, not to say that no one does it. There's a lot of people that do it, but it's just not as common. Like researching non-coding RNA and RNA interference. I want to share some things. So the connection that we made about nothingness from physicists studying the cosmos indicates that nothingness is the necessary balance created by the combination of antimatter and matter. With this recent growth in biological understanding of the power and presence of non-coding RNAs, I wanted to consider the similarities in the creation of nothingness by non-coding RNA and its role in maintaining equilibrium in the human body. I turned towards a wonderful review article titled Non-Coding RNAs in Disease: From Mechanisms to Therapeutics by Namath and colleagues, published in Nature Reviews Genetics in March 2024, discussing the emerging roles of non-coding RNAs in various human diseases. It validates multiple things. Number one, non-coding RNAs are a diverse group of RNA transcripts that are not translated into proteins, but are crucial regulators of gene expression and genome organization. Their dysregulation is implicated in diseases like cancer, cardiovascular diseases, neurodegenerative diseases, and even immunity to infectious diseases. And I will mention, these are just 4 examples that they listed out, but the reason why they chose these 4 is these are the most prominent causes of death in the United States and in the world. And so the role of non-coding RNAs in balancing equilibrium and then the effect of dysregulation of non-coding RNAs exists in pretty much all diseases we know now, but they focused on these 4 because these are the big killers. Okay? Non-coding RNAs are frequently dysregulated in various cancers, acting as oncogenes or tumor suppressors. They included some specific examples, which just, if our viewers are interested, if they want to research more, non-coding RNAs encoded peptides are also being explored in their roles of cancer. Like I said, there are some non-coding RNAs that do create regulatory proteins. Non-coding RNAs are involved in processes like apoptosis, proliferation, and cardiac remodeling. Then we also see dysregulation of microRNAs in Huntington's disease, Parkinson's disease, and more. They're also involved in immune defense, highlighting its role in immune function and potential therapeutic. The way that this could be clinically relevant is we can use non-coding RNAs as biomarkers for cancer. Like we said, if there's dysregulation, which could be over transcription of a non-coding RNA or lack of transcription of a regulatory non-coding RNA, we can then use that as a biomarker to say, okay, this person is more likely to have cancer because they don't have that same silencing net zero regulation of cancer. Same can be said for having therapies that either replace or eliminate non-coding RNAs that are related to cardiovascular disease, neurodegenerative diseases, and then immune response to infectious disease. I will say non-coding RNA therapy has been attempted, but from what I understand, the trials thus far have run into a lot of off-target effects that can lead to immune-mediated toxicity, which is understandable. I will mention there was one really cute review article that I won't go into the details of, but I did want to share it because even the title like perfectly wraps up what we're talking about, but almost in a different way. There was one review article titled "From Dark Matter to Star: Insight into the Regulation Mechanisms of Plant Functional Long Non-Coding RNAs" by Chen and colleagues in 2021. This provides an overview of the molecular mechanisms and functions of long non-coding RNAs in plant growth and development. They go into detail about the role of non-coding RNAs in regulation of gene expression and detail its interaction with RNA, DNA, and proteins. And while we will not discuss the specifics of that, I've added it to the show notes if you're interested in reading the full article. I was mainly drawn to it because of the direct connection of non-coding RNAs to dark matter. The authors discuss the previously unknown dark matter identity of non-coding RNAs and its transition to be a major player in gene regulation, therefore designating non-coding RNA's new title of the star. I thought that this was super cute, although I do understand that whenever they were using dark matter as a, way to describe non-coding RNAs, they weren't saying it because of the whole science of nothingness concept that we're talking about. They just said that because they were using the metaphor of something that is unexplored and unknown and vast. And so that's why they said that. But I still think that it's a really interesting connection that we're making that I haven't seen made yet. And that is the whole symmetry and canceling out of antimatter and matter, or antisense RNA and RNA, to create this equilibrium of nothingness. And then I won't dive into the specifics of this, but I do want to acknowledge that this is also seen on a big scale in the immune system. Think about what antibodies are. Like, the whole thing of antibodies is they recognize foreign bodies, bind with them, and then cause them to basically be deleted. And it isn't in the same way as like antimatter and matter or antisense RNA and regular RNA. It is usually because it tags the foreign body for clearance via the immune system, or it prevents like a virus from, being able to infect cells. But still, in that same way, you have this combination of object, anti-object, and then the equilibrium of nothingness that goes with it. This was such a fun mental journey for me to go on. Like, I need to know your thoughts.
I mean, I think it holds better than you think it does, because I think it's the exact same phenomenon of, it feels like, I think if we can figure out what dark matter really is, it's going to parallel this. Because, I mean, imagine if, looking at RNA, what if we were only able to see RNA based off of the proteins that they produced? Like, only the proteins were observable to us, but then the RNA was missing. We'd kind of be in the same boat of like, we'd have all these proteins and say, all right, these proteins are coming from somewhere. We discover RNA. But if we are just trying to then from that point discover non-coding RNA, we'd have this thing of like, it doesn't produce what we recognize it as, but we still know it occupies the same space. I mean, that deeply parallels it. I mean, dark matter, it's like, it has a weight. It just doesn't interact with light. Non-coding RNA, it's like, oh, there's still like the single strand ribonucleic acid. It just doesn't produce proteins. And then for, what you're saying with antibodies and like nullification of viruses, it's like, oh yeah, they're both still there. It's just the interactions that we normally associate with them that's no longer being expressed. So, I mean, I think there's, for the nothingness that we're looking at in terms of dark matter, I think there's a very, very clear parallel here that I'm struggling to put more clearly, but no, I see where you're coming from here. I love it.
I do just want to emphasize, like, one more thing before I dive into what you just said. Because you're talking about, I guess I'm, like, having a hard time verbalizing it, but this idea that the universe and nature spends so much energy developing things that don't produce anything, right? Like, non-coding RNA, it still takes energy to transcribe that. Antibodies, think about how crazy it is that our bodies produce receptors for things that are not within our body. And your body produces antibodies against pathogens that you've never experienced. Your body produces random antibodies. And the fact that we produce something that has nothing to do with us is kind of wild. Like, I don't think that people really grasp that. Like, the immune system is so beautiful in so many ways, but that is so crazy. And I'm trying to, like, I'm having a hard time finding the words, but linking it to what you were saying with, there is this desire. There is this like, active production of these things that don't create anything. They just balance things out. If anything, they eliminate things for the sake of that balance. It's just so weird. Like, because whenever we think of something being created, we think of it being productive. And we think of, like, the accumulation of things. But I think part of this whole narrative and the way that we can, like, extract truth in terms of an experiential level, like, this isn't scientific truth, but this might speak to our existence of life. Like, this idea that clutter is kind of bad. Like, it is good to have something to eliminate the clutter of the world, release some of that energy, and to balance it out by removing. Like, we don't usually think about that being an option in terms of, like, physics level or microorganismal level. We don't really think about that, but sort of this idea of removal. And that's why I think that this topic is so rich for conversation as well, right? Before we started this episode, we were talking about this book that I found, The Experience of Nothingness, which I'll go into it. But even that alone, like, speaking to what it, like, the intelligence that can be gifted upon to you with removal. Not just removal from an environment, but, like, removal of your being as well. Like, the experience of nothingness. How does that change you? What can that do for you? You know, it's just amazing to me that, like, that is how this universe was born. That is why we're here. Surely that must mean something. Like, surely we must have to go through that process to find meaning. You know?
Well, again, I mean, I want to say that I think the DNA agrees with you. You know, it's just like, it's not just the universe saying we need to actively create this nothingness. It's DNA saying the whole same thing. It just, you know, most of our DNA needs to code for non-coding RNA. It's like, it's the same reiteration of we need nothing space. And again, it's like universe says we need nothing. Like, the whole central dogma theory says we need nothing. Again, you could take it to, like, the spiritual tradition, you know, thinking of monks saying, oh yeah, you need nothing. It feels like it's this point that is just being rung over and over and over again.
Like, and even if it's not emptiness nothing.
Or like an active nothing, even.
Yeah, like, what we keep going back to. Zero isn't just zero. It's negative a million plus 1 million. Like, it's that balance. It's an indication of balance. So of course it makes sense that disease is going to occur whenever you have an imbalance of that. That makes sense. Like, the nothingness also is the identity of balance in that way. I do want to give one quote to launch sort of our humanities dive into all of this. And this is from chapter 10 of A Universe from Nothing. And he says, "Nothing always produces something, if only for an instant."
I wouldn't believe that was coming from a physicist in like any other conversation, you know?
Dude, physicists are like the deepest people. Honestly, a lot of like the best theologians have been physicists as well. Do you want me to introduce the experience of nothingness? Or do you have like some humanities stuff that you want to go through?
The whole idea of that we don't want genes to be expressed, but we don't want to get rid of genes. Because once you get rid of a gene, it's gone forever. So like, how do you navigate that? And there's like no evolutionary incentive to like truly get rid of a gene. And how do we regulate that? Seeing nothingness as a way, or like creating nothingness as a way to hold on to something while also not engaging with it. It's almost kind of like choosing silence in a conversation, or, you know, yeah, again, from that very human side of like choosing to be silent with something. You know, like, in a way, it's still like a usage of voice. It's like an active decision, but at the same time, you aren't saying anything. And that's an incredibly powerful thing. Like, I had like memories that rushed into mind of like being in elementary school, and this moment like the whole classroom is a mess, and like the teacher's been like trying like yelling at everyone to like get back together, and like it's not working. And then all of a sudden the teacher's just like dead silent. And in like 5 seconds you hear everybody noticing, they're just like, because they know it's serious. But it feels like this amazing usage of that kind of like active nothingness, like active silence, that does bring everything back to order.
Understanding that productivity does not need to be clutter.
Mm-hmm.
It doesn't need to produce a thing. Like, something can be very productive through balance, which we now know through this deep dive often appears as nothingness.
I'm starting to see nothing more as like a relative judgment more than anything. Maybe my own definitions of nothingness that's emerging is kind of like becoming like a relative nothingness more than anything, of just presents that as nothing, but because we're only focusing on one aspect or trait of the thing itself, unable to realize that it is a larger, multifaceted thing, but unable to do so because we only recognize it one way.
Yeah. I do have to ask, because you've done so many like silent retreats, spiritual retreats. Do you have anything to say about the experience of nothingness from the silent retreats that you've done? Or like the spiritual deep dives that you've done? Is it the nothingness that pulls you through to a different place? Or is it just like removal from society?
I think for me, it's about you can only process so much at once. And I feel like if you are caught up in the, you know, daily rhythm of life, there's just so much else, you know, basically everything that isn't the daily rhythm of life that you don't get a chance to properly engage with. And it's only by, I guess, removing that you have a chance to engage with everything larger than what makes sense to you on a weekly schedule. So that's how I kind of understand it. But, you know, I guess treating solitude or just kind of like retreats, that is just an active creation of nothingness, isn't it? It is like,
It is.
again, treating it as, it takes energy, it takes cost, like it is something you have to do. It's not convenient to be able to go in and create this place where there is nothing.
Yeah, and I mean,
or less.
I know you, and you meditate all the time too, like if not every morning.
Try to.
Even like whenever I was reading this, even drawing lines to the tenets of Buddhism as a philosophy, like Buddha, in order to become enlightened, completely removed himself from society and did nothing. Like, he didn't eat, he didn't move. I mean, historically, he did nothing. And whenever you look at the foundations of Buddhism as well, there is this universal, cosmic symmetry, balance in a cycle that I'm pretty sure reverts back to nothingness. But the nothingness is not empty. It's the birth and the death.
Oh, so it's that second definition, that net neutral nothing. I mean, the place I was thinking about this too was just with Ikebana flower arrangement, you know, like the Japanese floral arrangement practice, which is very deeply informed by, you know, like Zen Buddhism, And there is a huge conversation around just the manipulation on, like, organization around empty space or void space. You know, like, it's almost about the space that isn't flowers almost as much as it is the space that is flowers. And, like, if you do try to treat it as, you know, like, a rose bouquet where just kind of like every single visual space is a rose and there's nothing else, you've completely destroyed the whole point of it. And it is when you have just what seems like a whole bunch of nothing that it does create something fuller or richer or just an ikebana arrangement.
Yeah.
And that is what I do think about that.
Yeah. We talked about overstimulation and desensitization in our insulin episode. And I think that the role of nothingness spiritually, and like you were talking about it visually just now, but I feel like part of that combats the overstimulation and desensitization of the world. Like our brains are very plastic. They will habituate to any environment that we're in. And so I think by allowing space for nothingness in our lives, doing things that aren't extremely significant, experiencing things that mean that you're not like the most important person in the world and your life is a movie. I think it does allow our brains to recalibrate and experience the world as it is. In a way, it's sort of like this recalibration of reality. And what I would like to end on, or at least for me, was whenever I was diving into my reflections about the creativity of nothingness, I came across this book called The Experience of Nothingness by Michael Novak. And just reading some of the pages in the sample absolutely blew me away. He discusses the role of the experience of nothingness in grounding someone in the experience of reality. And what was interesting is he writes about all of this in a way that is particular to the American and the American experience, which you don't see often unless it's talking about like some sort of pioneer or frontier attitude. But he discusses basically the American version of European nihilism. I will say though quickly, because like I'm sure a lot of people will look this up, look into it. I'll just be really open. Later in life, Michael Novak was very politically active. You know, he became a political extremist. This book is not a politically extremist book. He does have some other works that are like very pertinent to politics. This is a philosophical book, the same way that Oliver and I really enjoy Gravity and Grace, and I would recommend everyone to read it. Like earlier in her life, she was a political extremist, but her book is not a political handbook. The same thing can be said for this. Although he was a major political figure in his personal life, I would recommend anyone to give this book a try. I think that it has some really profound themes that it explores, but all in all, he talks about how integrating and accepting nothingness into your life with a strong moral perspective can allow you to see what is real and what is not real in the world, especially as it relates to like the systems of, you know, our social systems. But I do want to read one quote from here. So this is one quote from the book, The Experience of Nothingness by Michael Novak. Honestly, I teared up whenever I read this quote. I don't know if I will again. But open quote, to be faithful to the drive to question is to accept despair as one's due, to accept risk as one's condition, and to accept the crumbs of discovery as joy. The darkness is habitable. Those who accept the darkness as their lot are instantly secure, not through some newfound solidity, but through the perception that insecurity is a man's natural state, a truthful state, a healthy state. Do you have any ending remarks, Oliver?
I got nothing.
It's a good one.
All right. Well, everyone, thank you for joining us for episode 5 on the science of nothingness, dark matter, absence, and non-coding RNA. Oh, yeah, if you have any questions for us, you can reach out at media@octorum.com.
That's our email. We also have an Instagram, octorum_podcast. And you can find us on our website, octorum.com.
And if there are any topics or strange connections that you would like us to cover in Octorum, please send them our way.
Yes, we love hearing from you. We're very responsive, and we really appreciate your time.